group. First of all, I'd like to welcome our beloved principal, Dr. C.T. Jayadeva, sir. I welcome you, sir. Sir, are you online? Hello. Jayadeva, sir, are you online? Okay. Once again, I welcome our beloved principal, Dr. C.T. Jayadeva, sir, on this occasion. I welcome you, sir. I welcome our beloved HOD, Dr. G.M. Satyanarayan, sir, on this occasion. Welcome you, sir.
Thank you.
I welcome today's, the speaker for this 3 days workshop, Govind.K.Handigol, who is the CEO of CADEM Innovations, Hubballi. I welcome you, sir. I welcome Naveen, sir, who is the MD for this Naveen Engineering Services, Hubballi. I welcome Naveen, sir, and he is the key person in organizing this event. So thank you very much, sir, for this.
Thank you, Vilas. Thank you.
I welcome the participants, the faculties and the students from various engineering colleges and our college also. I welcome all the faculties and students. I welcome the industry persons who have registered for this this webinar or this workshop. I welcome them also. I welcome our Tech with Mech team members. Okay, for this on this occasion, I welcome all the Tech with Mech members. Now I am going to read a brief profile of our speaker, Govind.K.Handigol. He has worked in CADEM Limited Group, Mysore for 5 years. He has worked in companies like Carbo Tools India Private Limited and Notam Engineers Private Limited, Pune, Maharashtra for 3 years. Presently, he is the CEO of CADEM Innovations, Hubballi, and has 15 years of experience in software training and project developments. His specializations are tool design, mold design, CAD and CNC. I once again welcome Mr. Govind, sir, for this 3 days workshop.
Thank you. Thank you.
Request if Jaydev sir is online, principal is online. I request our principal to say a few words on this occasion. Sir. Over to you.
Good afternoon to everybody. This is Principal Adichunchanagiri Technology. I am also from mechanical branch. Hello. I am very happy. Vilas, I welcome all the participants and also the Muhammad also. I wish this session will be very useful for our mechanical engineering students as well as faculty members. I'm very happy to listen to the CADCAM webinar. I'll also be with you only. Please carry on. I wish you best of luck.
Thank you very much, sir. I request our board HOD, G.M. Satyanarayan, sir, to say a few words on this occasion.
Good afternoon, my dear student friends. As you know that CAD/CAM applications are used to both design a product and program manufacturing process. You are aware of the applications of CAD/CAM also. CAD software uses the models and assemblies created in CAD software to turn design into a physical the product, the toy. The CAD is extremely important. You know that it is widely used to design and develop products to be used by consumer. Then you know the CAD is a better, quicker, easier, less expensive than manual drafting, what were used in the past. Then CAD is an important industrial art extensively used in many applications, including architectural and industrial and aerospace industry and many more. In this context, AIT Technic with is shop principal for his cooperation. I welcome you to this webinar also. I thank the faculty coordinator Vilas Patwe, as well as I thank Rakshish M. Shetty. They are organizing this event. This is the, I think this is the third event, I think so. Okay. Anyway, these people are doing a wonderful job under this pandemic situation. I welcome today's expert, Govind.K.Handigol. He's the CEO of CADEM Innovations. His expertise in this particular area. He may highlight advance the features in this particular CAD/CAM technology. Welcome Mr. Naveen also. We also had by Mr. Naveen. Thank you. I welcome you, Naveen.
Thank you, sir. Thanks a lot.
I thank everybody. Okay. Please go ahead, Karthik.
Thank you very much, sir. Now I request Govind sir to start the session. Please, sir, Govind.
Okay, thank you. Yes. Good afternoon to everyone. I am audible?
Yes, sir. Go ahead, sir. It is audible.
Fine.
Yes, sir. It's audible, sir.
Yeah, fine. Yeah, today I would like to start with the CAD/CAM CE technology. Once again, I am welcoming you all, the students and professors, and the principal and Naveen sir for this session. Thank you for giving an opportunity to present on some advanced technology, advanced features in CAD/CAM CE also. Let us start with the CAD technology. Generally, today I would like to start with the introduction to CAD software, then engineering software in the market and international markets and its applications, then live demonstration on CAD/CAM software, then how to go ahead with the manufacturing processes and how to releasing the manufacturing drawings for the workers to manufacturing and other applications. And finally, we have the discussions and queries and question and answer session at last 5-10 minutes. Generally, the CAD, it is generally made up of computer-aided design. Aided means with the help of. Earlier days, we used to go for manual drafting. It is going to eliminate it from the computers, and almost all the design concepts, the manufacturing drawings and other applications have shifted from computer aids. Like that, the CAD and CAM and CE also, they have shifted from the manual applications to the computers. It is one of the example for the 3D model, the CAD computer-aided designing, where we can visualize the third dimension, means the virtual imagination of object in the computer screen, where we can understand the real concept of the object. We must feel that the object is inside the computers, and then we can go for the virtual manufacturing concepts. It is one of the example for Hero Honda cylinder block. It was the order from the Hero Honda Motors Limited from Jalandhar to Paranjape Autocad Satara, where they were the vendors for the Hero Honda Motors. We have developed in the year 2000 only. The software was used AutoCAD 3-dimensional drawings. Then they have imported this 3D model to the AutoCAD software, and they have solved their problems. But we have made the model in the year 2000 while giving the corporate training programs for the industrial persons. See, generally the new product development generally go for the PLM cycles, product life cycle management. Generally we used to go for the initially we have to understand the problem statement, then we have to go for the conceptual designs, then we can go for the prototype design, then virtual validation, Then again, we have to go for analyzing the products with different analysis concept, thermal, buckling, structural, and some other the CAE applications, the Gambit and other softwares we have to use. And then again go for the CAD, the computer designing, modeling, modification to the modeling, then go for the drafting, then go for the CAM application, the computer aided manufacturing. Yeah, please. You can't see? Right? Yeah. PPT I am showing you.
Govind sir,
Oh,
go to the presentation slide.
oh, I have not shared, I think. Sorry. No, you can?
No, Govind. Govind sir,
Ah, yeah.
there is an option.
It is showing, it is sharing.
Whether you have copied your PPT on your desktop?
Yeah, it is there. It is showing PPT here. Okay. Once again, I go entire full screen option. No, you can see. Sorry. Initially, I show some slides. No, you can visualize.
Yes, sir. It's good. You can see.
Yeah, it was the Hero Honda cylinder block that we have developed this for the corporate training programs in Maharashtra, Western Maharashtra. It was the order from Hero Honda Motors Limited in the year 2000. While giving the corporate training program for the Paranjapay Autocad Satara, we have developed this model in the Autocad software, Autocad 2000 version. And while giving the corporate training programs, we have developed. And then they have imported this model into the Autocad software. Then they have solved the problems at this work, and it was used in the year 2000 for the Splendor. The Splendor had made more than 10 years, 15 years business for the Hero Honda. Then just went from these presentations. Yeah, generally we used to go for the design concepts with the help of computers. Design takes the cost wise, it is very less, the 5%. The material cost for any product, new product development, the material cost will be around 50%. The labor cost will be 15%. Then the rest all the parameters, the manufacturing and other advertising and other marketing applications, they have the 30% of overheads. Whereas for design and development activities, it will take much more time, the 70%. It influence on the product. Then product means it is set up the assembly of the different parts, not a single part like that. Then it is going to, material cost is going to influence 20%, the labor and the marketing overheads, it influences the 5%. But whereas the main concept of the design, because generally people go for the understand the problem statement, then they can go for the understanding the specifications and constraints, and working with the atmospheres, the temperature control, then ergonomics and serviceability, safety, aesthetics, and manufacturing. All those are going for the important for the design concepts. These all purposes. So it is going to influence the 70% of any products. Generally, the CAD contains the modeling. It is generally, again, if you see any objects in the two-dimensional, that is called two-dimensional, the 2D drawings. If you see any objects in the 3D, that is called as a one model. If you see any objects in x-axis, y-axis, z-axis, that is called as one model. The process is called modeling. And the modeling or model is going to categorize into three categories: wireframe modeling, surface modeling, and solid modeling. What is the main difference means? See here, if you take one example, if you are building one compound with the help of sticks and tags, where you can see the inside is completely, that considered as a wireframe modeling. If you build the same compound with the help of some curtains or sheets, that is considered as a surface having infinite less thickness, almost equal to 0. If you build the same model, it is going to consider as a solid model with the help of bricks. If you build the same compound, it is considered as a solid model. If I remove one brick, again we get the material in that. Solid means it is full of material, having mass properties, moment of inertia, center of property, other physical properties, it would be utilized for the further applications like CAE and CAM applications. So that the modeling considered as a wireframe, surface, and the solid. We can convert wireframe modeling into a surface to a solid. Again, we can extract vice versa solid to surface and wireframe geometry also. I show you while giving the live presentation. Again, CAD includes assembly, drafting and detailing a GD&T, the sectioning, the rendering, the mechanism, design, and physical properties. Assembly means the checking the interference between the components. Assembly can go for the clearance checking, interference checking, and surface contact, and other physical properties which would be utilized for the further mechanism designs. And to see the internal portions, we have to go for the sections. And drafting and detailing and the GD&T concepts. For end result of the all the components are going to manufacture. It requires the drafting, detailing, and GD&T. GD&T means geometrical dimensioning and tolerance, which is having the 14 symbols. The rendering means we can go for the visualizing the components, the virtual imagination of the objects. See here, again, generally, we must know what is the important and why, how, and when the typical CAD/CAM same applications are used. That is very important. Mostly 55% designers never ask for the any learning things, how the designs and what are the things, what are the details they are going to teach and other parameters. It is very important to understand what are the things they are going to learn in the almost all the CAD applications. Features are very important to create any modeling applications. Features having the no mass and no volume available to help the creating the models. And these things are as a reference models. I show you while giving the live presentation. See, features are very important to create the different concepts. See, it is one of the another example for the wireframe modeling. These are the made up of line structures, the curves, basically line curves. These are made with the help of reference geometries, the 3D points, the planes, the wireframe geometries, and we can go for. We are generating the surface between non-linear curves. These are the non-linear curves having the passing through different planes. We are generating the surface. We can add the thickness for the surface, but right now surface having infinite less thickness, almost equal to 0. We can add a thickness for that one. See, these are the non-linear curves, the wireframe geometries. We are generating the surface for the any type of example. This is one of the car body. And the solid model, see it, one of the example. It could be aluminum die casting, but we can go for the applications like the solid model. We can go for the machine. We can go for the designing material. If I drill it, I'll get material here. See it, it is an assembly example. Yeah, it is one of the fixture assembly. I think you might have heard of the jigs and fixtures. Jigs are used to hold and locate the workpiece and get the tool. Fixtures are used to hold and locate, it does not get the tools. See, these things are going to ask in your interviews. Students, it is a very important jigs, fixture, types of fixtures, inspection fixtures, grinding fixtures, drill jigs. Like that, you must know all these things, and you must know if we give any example, any component for the mass production, you must be able to design fixtures or jigs. That is very important. Yes, as I have told initially, for the Hero Honda cylinder block, this was the drawing, two-dimensional drawings. The top view, bottom view, the section. See here, the simple section. The another section we have taken at this hole. See here, we can have another section in detail. This is having different radius, and here it is having radius 460 radius for the Hero Honda cylinder block. See here, nowadays the advanced technology have the 3D sections where we can understand the drawings by making one or two components with sections, whether these things are going to assemble properly or not. Like that, we can visualize in the simple sections. and the rendering, the virtual. If you have new innovative product, but you must show to the customer that the component, after the finishing the component, how the object is going to look, so that we must able to understand how the end new innovative product would be visualized. You must show in the computers like that. It's generally it's made up of lights, materials, background, landscaping, other aesthetic, other things which are going to help for the aesthetic looks is very important. See, what are the softwares are used in the generally for the applications, industrial and educational applications. The CAD divides into three categories: lower end, medium end, and higher end CAD softwares. Lower end generally you have used the Autocad software in colleges and Archicad for civil, CADing, electrical, like that. If you go for the medium end CAD software, as a good syllabus, you might have heard about the solid software. Generally, it is going to use for the educational purpose. Then you can go for the complete applications. Almost all the medium scale industries, they are using the SolidWorks as an medium scale industrial CAD softwares, and it is one of the best softwares used for the your conceptual design things. That is very important. And with the help of SolidWorks, you are going to get the jobs either in SolidWorks or in TOEI for the fresh engineers. For freshers, to get the jobs in the design, generally people are going to ask in the experience. But for the freshers, you are going to get the jobs either in SolidWorks or Pro Engineer. That is, it is from the PDC company. The parametric nowadays, the name is Creo. The Creo elements, Creo parametric, like that. It is basically from the basic name is the Pro Engineer. This is from the PTC, Parametric Technology Corporation, US-based company. It is one of the 10th largest software company, and more than 35 to 40,000 customers are there worldwide. And in India, we have got more installation than the SolidWorks. More licenses are sold out, so that more number of opportunities you are going to get in the Pro Engineers. We are also going for the PDC master trainers. Since last 15-20 years, we are using PDC products. And if you go for the CADIA, computer aided three-dimensional interactive applications, it is from the Dassault systems. And you might have heard about the Dassault systems. India is also purchasing many aeroplanes from Dassault systems, and the world mostly used for aerodynamic applications, sheet metal and advanced surfacing. The CADIA is one of the best software. And Dassault systems is the main company, IBM product. They are releasing the software, that is CADIA software. And we were also purchasing the aeroplanes very recently from the Rafales. They are also manufacturing CADIA software only. And Boeing, they are Airbus and PROE and CADIA. Airbus is a UK aeroplane manufacturing company. Boeing is the US based worldwide, almost all the worldwide customers they have. And Unique Graphics, it is one of the best software for the solid, the hybrid design product for the development of the hybrid design products. Ideas in integrated design engineering and analysis softwares. It is merged with the Unique Graphics. The latest versions are NX. NX series have merged with the Ideas and UG Siemens products. These are the German-based company. For visualization applications, you have the software called the finishing the product. After the end result of the product, the object should be visualized properly. For that, you have 3D Studio, Max, Maya, and Lumina. These are the softwares for visualization applications where the Indian and the international markets are using. Here, worldwide customers generally measure in Indian groups: Mahindra, Brex India, automobile sectors, Ashok Leyland, Tata Motors, Telcon. The Tata Motors initial name is Telcon, Tata Engineering Locomotive Company Limited. When the Indica car introduced, they have changed the name as a Tata Motors. Bajaj Tempo, Renault, Hero Groups, and Nissan, Honda, Hyundai. Almost all the automobile industries. If you go for home appliances, LG, Sony, Philips, Panasonic, Onida, and R&D and educational segments. See here, HAL, NAL, DRDO, IISc, IITs. See, the technology flow from the industry to the educational institution because of human resource development. The private software company, they have introduced the software into the government sectors, that is to main IITs. Then IITs to RECs to the BTU, other engineering colleges, then NTTF, diploma technical boards. Like the technology flow from R&D, from the private institutions, private engineering colleges, and then it introduced to government sectors also. And OEMs, original equipment manufacturers, Tata, Bajaj, Bench, these are the OEMs. And service industries. The people are working more than 1 lakh, 2 lakhs employees are there, almost all these companies. GE has got more than 1.5 lakhs worldwide customers. They are using Pro Engineers. Maximum of our students and our people are working with the GE, GM, and TCS. They are working with the Japanese collaboration with the and UK's collaboration in aerodynamic applications. West Globals, they are into CAE development and geometrics, General Electrical, and General Motors, CR. These are the service industries. They are giving solutions for almost all applications. And agricultural, John Deere, Tafe, they are using Creo Elements, the Pro Engineer softwares. Since 20 years, they are using. And very recently, the person who worked with the John Deere, right now he's working with the new incubation center at BB Engineering College. He has got more than 20 years worked in the US in 20 years and in Pune in John Deere company only. Now he's working with the one of the top management profile in R&D development in BB Engineering College. Mr. Kulkarni sir, something like that name is there. And mobile applications. See here, what I would like to say, these are the PTC products. See the Airbus, Toyota, Volkswagen, Siemens, Dell laptop, what they are using. That is developing Pro Engineer only. Whirlpool, ABB, see here. Worldwide customers we have. See here, the PTC is one of the best software to understand, to start with the concept. See here, the fundamentals of the parametric modeling through Creo is very important. Generally, we would like to design the fundamentals to the advanced applications in mind. Then we are also going for the different standard projects for the engineering students, as well as the industrial applications, as well as the service-based applications. Those can be utilized for the sheet metal, drafting, and layout modeling. See here, what is my intention? You must understand the basic engineering drawing. Then you are going to understand the modeling concepts. What is my intention? I think you might have studied it, but even though some important concepts I would like. Drawing is a graphical representation of an idea, a concept, or an entity which actually or potentially it may or it may not exist in the life. Generally, drawings are categorized into aesthetic as well as engineering drawing. Aesthetic means generally it is the simplest line drawing and some paintings. We must convey to the customers, we must give an idea as an artistic look to understand our interpretation. Generally, engineering drawing, which includes information regarding the geometries, tolerance, material, heat treatment process, surface coating, and part documentation, part number, assembly concept, and sectioning and other parameters. See here, the complete detailing applications with the help of datum things I will explain you later. But we must able to show the drawings. It should be properly readable and full informative, so that it is language of engineers. We can't explain all these things. We must convey it through drawings only. The people are going to understand the drawing and manufacture the products. And drawing sheet sizes, the presentation, all things, first angle. See, these things are going to ask for the freshers up to 1 year level of experience students. What system of cone can be shown to the first angle of projection. These are very important using second and fourth angle. Sketches and orientations are very important to understand the drawings. Sketch is a backbone for the solid models, and we must use more constraints, not dimensions here. The same the model can be visualized. Means here we are giving more dimensions. Here we are using more constraints. These lengths are equal. These radius are equal. So we are showing only one radius. Symmetric about the axis. The total lengths are equal, like that. We must use minimum constraints and maximum constraints and minimum dimensions for development of the any 3D models. See here, symmetric concepts, the 3D concept of working, the 3D sectioning with the help of coordinate systems. See here, how if the components are symmetric, generally we must show the simple applications. See here, how to make the model, that is very important. See here, we can make the model, and if you want to cut it, we must create the model, then we have to cut it. The two features are going very important. Some people, they go for directly, they create the two sketches, then they make it. For castings or forgings, that is different concept. But generally, we must know how to manufacture. That is very important. Understanding manufacturing concepts, we must go for the applications as per our requirement. And here, the purpose of sections are very important. The purpose of sectioning is very important. We must know the sections, how the sections are there, what are the types of sections, what are the revolve sections, full sections, half sections, and what is the offset sections, because these are very important. What is the offset section, what is the full section, what is the half section, allied sectional view, these are very important. And the material hatch patterns and dimensioning methods are very important, and surface finish symbols. To manufacture, to release the manufacturing drawings, these are all very important. Apart from this, you have in college what you have studied is the tolerance, types of tolerance, unilateral, bilateral, symmetrical tolerance. These are very important. You may have to face the problems. Just I will tell the basic concept initially. It is one of the MCB cover drawing which is developed in the 2D. Just I show you basic drawings, because initially more than 20 years people they have used AutoCAD as a basic software. So we must start with the concept to understand the basic of AutoCAD. Generally, main purpose of AutoCAD is used to create the two-dimensional drawings. Just I show you. See, this is the model. This is the to manufacture any component, we must understand. See here. See, this is the core, the main part of component, and cavity like that, and this is a parting line where the parts are going to part. Just to give some hints to understand. This is mode-based assembly. See here. This is mode-based assembly. Again, we are going to study this one at our third session, but we must know how the drawings are there, how the manufacturing drawings. See here. For freshers, it is very difficult to understand. Okay. To have only one assembly, see here, how many inserts are there? The core cavity inserts, the sub inserts, and types of plates. Complete applications, the ejector pin drawings. I explain you all those things in detail, but we must know how to see before the three-dimensional drawings. AutoCAD is one of the software. Just I show you the AutoCAD modeling concept. so that you can understand the 3D concept of working in the higher end CAD software. Just I'll go for the new file. I go for the 3-dimensional. I go for the setting my view in the 3D. See, right now you can see the x-axis, y-axis, z-axis. I create one box here. I go for the shaded. It is this. It is full of material. How to understand that it is full of material? I create one sphere and one cylinder and I cut it. I'm creating one sphere here. I go for creating one cylinder. Center point of the cylinder. Then I go for the base radius. Just I create one cylinder. Then I go for subtract. I go for one command called subtract. I would like to remove this solid model and these two. See here. As I have told, solid means it is full of material. It is full of material, as I have told you. No, it is solid model. Just we are working with AutoCAD, the basic software. I make the copy of this one. I make the copy of this one. 3 copies. And I would like to convert this into a surface. I go for X enter. It's going to convert into surface. I delete, it is surface now. I delete this surface here. It is hollow. Surface means hollow, as I have told. Again, I want to convert this one into a solid. Again, I go for X enter. It is surface now. These are the surfaces. Now, again, I select these and I convert into wireframe. Again, I go for X enter. The line structures. Now it is made up of line. The wireframe, surface, and the solid. Generally, CAD softwares are going to develop through these concepts. Now, we can convert a wireframe into a surface also, surface into solids also. Again, I can add the material between these 2 lines. Enter. Surface. I can add it. Again, I can add the surface for these also. We can convert into a solids also. And I go for the deleting this space. I go for deleting means I can add the material for the solid model. See here, we can add the material for the solid model. Again, I can go for the extraction from the solids. Again, I would like to move along with the path. I go for the extrude face. I would like to go for the face. Right, I would like to go for the path. See. Then I go for the shell applications. Shell means adding wall thickness for all the face of the object. By removing the top face, I give 5 mm thickness. See here. It is solid model only. It is solid model only. But we have made shell option. I can extract the surface from the solids. I go for the copying the faces. Copying these faces outside. See again. We have extracted a surface from the solids. Again, I can convert this to a solid model. See here. Again, solid. We can extract the surface. Again, I go for extruding this surface for hybrid design products. See here. Now, this is surface, this is solid. I have extruded an arc just now. I would like to cut with the help of slice command. I want to cut this solid model. with the help of this surface. I would like to keep both. It has cut. See here. Now I would like to move this one. Move. Here. It has moved. Again I move this arc also. See, I would like to move this also. Here. Means surface through solid development, means hybrid design products. So that you are going to understand. Initially we have made one solid model, we have converted it into surface, we have converted it into a wireframe geometries, then we have created a surface through wireframe geometries, then we have extracted the surface from the solid geometry, and we have cut a solid model from the surface. That means development of a hybrid design products. With these concepts, we are going to understand how the higher end CAD softwares are there, how the models are developed in the higher end CAD software. The basic concepts of the AutoCAD using with the different models. What is the drawback of AutoCAD is that they have not made parameterized model and they are not built with the associative between different models. Parameterized means depending the parent-child relation between the different features. See here, it is one of the local order, the 3D model. See here, the 3D model. It is the software we are using is a CATIA. The software what we are using is a CATIA, and just I show the section here, the 3D section. See here, what the model has made. If I select this plane, see it has cut like this. See here, the different features for this model. Any planes you can have with different planes. We have opened 2-3 software. It is going to show you slowly. See here, how to make the model. That is very important. You can rotate the sections also. You can have the rotation between different sections. Like that, the object can be visualized in front view, all the views, how the object looks. Front view, top view, side view, left side view, right side view. Suppose I would like to have the hidden, you can have the view in hidden mode, like that, a single viewport, 2D model, like that. It is one of the example. Under 2-3 examples I show you. It is also one model. The more drafting. See, it is one of the gear composing design. See, this is of the one model. We can visualize. Let us see how this model, what is the approach for the modeling we have given. Just I go for the scanning the tools. Yeah, see here. Right now I have not shown the drawing of this one. I have the drawings also. See here, the first feature, we are adding the material. Second feature, again adding material at the top side, then remove the material. Isn't it? Remove the material. Base features. Again, if the requirement is there, you have to add the material. Then create the different planes. Then we have to go for the ribs, different types of ribs. Then at last we have to go for the finishing the with the help of fillets or rounds. Hybrid design, wireframes, then surface, then it can be converted into solid. See, now it is solid. Same parameters, different types of planes, points, lines, then create the surface, then it can be converted into solid. Surface and solid. See here. Like that. Like then at last you have to go for the ribs, the fillets, the rounds. Like that you have to make the different models as per the requirement. See here. Suppose if you would like to have the drafting views for this one, I go for the drafting application. Here, all views can be generated directly or directly. Let us start with the empty sheet. I would like to go ahead with the model. See here, the model can be oriented to different concepts. You can visualize as per your requirement. Let us accept it. Then you can have the projection of the views. You can go for the projection of the views. Left projection, right projection, top projection, like that, depending upon your requirement. Suppose I would like to have the sections. You have to go for the section here, simple section. See here, you can have the sections. You can go for the full section, half section, allied section. As per the requirement, you can plan it. Suppose if you want to create the projection of these views, you can have the projection, left projections, right projections, and automatically dimensioning. Automatically it is going to generate dimensioning. All these parameters you are going to get in the generative dimensions. If you have developed all the parameters in the part design, all dimensions are going to come here. The part design, the feature based application, what are the dimensions you are going to use it, and also you can go for the having the detail views. Small area can be enlarged and it can be shown. It is detail view and clipping of the views. You can go for the clipping of the views. I would like to keep only this much area. You can go for the clipping of the views, detail view. Say like this, you have to set the parameters. That is very important. And the dimensionless properties. All dimensions. See here, views, type of views, projection views, the sectional views, details, clipping views, breaking views, next drawing sheets, types of sheets, dimensioning, types of dimensions. See here, almost all these are very important for the fresh engineers. These are all very important to understand the basic concepts. Then we can go ahead with the other applications like that. Sheet metal design. See here, the sheet metal design. You heard about the sheet metal? Sheet metal is if the metal thickness less than the 6 mm, you can go for the sheet metal. Generally, so that sheet metal is the one of the manufacturing process. The flash sheet can be manufactured through punch and die concepts like that. The sheet metal products are different from the manufacturing process. Then I go ahead with the other software called the Pro Engineer. The first I'll go ahead with some basic things in SolidWorks. Then I go for the here. This is a model developed in the SolidWorks. See here. The PCB design, I have shown you PCB design, the model. The models, you can visualize the core and cavity for the PCB design. Yeah. By explaining the models in detail, I'll show you regarding the different components. Then the important part of the software I explain you in the Pro Engineer. See here. See here, just I open this component. It is TVS Scooty's part. It is a TVS Scooty's front panel. Okay. First, we should know how to make the model. See here, in model tree, you can see with the help of wireframes and surface design, the model is developed. After it is a fiber or plastic product or any material, how to manufacture, that is very important. To manufacture this one, the important is that you have 3 to 4 manufacturing. You can go for the cut approach. Nowadays you have 3D printers, but before that the people used to go for the manufacturing, the mass production through core and cavity extraction, the mold design. The total mold base, this is called total mold base for that component. I explain you in third session. After 2 days back, I'll explain you what is the core, what is the cavity, and other parameters. To manufacture this component, we must go for the complete this mold base. What is this part? Top plate, ejector A plate, ejector B plate, cavity plate, core insert. Just I open you, core insert. See here, how many fillets are there? How many radius are there? How to control these radius? This is core for that component, and the cavity for that component. See here, the core cavity like that. I take one section view. Just I switch on the plane. I take one 3D section. We have hidden the cavity. To understand it, we have hidden the cavity here. Yeah. We have hidden the cavity here. Just see here. See here, the section. How to extract the core cavity, ejector A plate, ejector B plate. This is the guide pillars, guide pillar bush, guide pillars, guide pillar bush, screw bush, rotating ring. The material is going to flow between core and cavity, and material is going to add. There is a gap between. I have hidden the cavity. Just I open and show you. Just I unhide the cavity. And again, I'll take the section so that you are going to understand it. See here. See here. The material is going to flow in between core and cavity design. Then you are going to get the product here. Like that. Draft is there. Then products here. There is a gap between these components. Because of time schedule, I'm not going to show you the sheet metal design. Just I explain you how the model and how the model planes, how the things are very important in the part design. What are the things? Basic things you know. Basic parts, all applications you know. But whereas how to make the complicated parts? What are the features? I show you. I go for directly new file. I create the one model here. I create 1 or 2 rectangles. I create one circle here. I add one fillet. Fillets are used to strengthen the corners. See, now I have made one model. See, these are the default planes. The part name, the right plane, top plane. You can rename it. You can rename it. We can control. See, very important commands as I have told you. The round. See here, fillets. For smoothness, you need to go for the fillets. You can add the different radius here. You can add the different radius at the corners. See here. You can add the radius. Variable radius fillet in single set or second sets or third sets. Variable radius. And I go for another set. I would like to go for the one full round fillet. See here. You can go for the full round as per your requirement. You can reduce as per your requirement, or you can go for the full round option. And we can add the different radius. Suppose if I go for the third set, see here, in third sets, I go for the one strengthen the corners. We have the options to create here. You can go for intersect here. At corner, you can go for intersect. You can go for the spear. You can add the spear. See here, like this. The simple model with different sets. You can create it. Then we can go for the patch also. See here, the model. If I go for one shell application, I would like to remove this face. See here, I would like this face and right here. The draft for the surfaces, very important. I go for one draft application, and then the neutral plane. Sorry, I go for the model in draft. I go here. Faces to draft, neutral plane. I would like to keep this one as a neutral plane. I can add the material. See here, it is added. The draft are very important in the Pro Engineer, because components are not going to eject. If you are not giving draft, means the components are not going to eject, and it has got its own calculations. See here, some basic features. Variable round, full round, like that. And suppose if you have different curves, I create one curve here. Go for one spline. Again, you can go for the round option. Right click, I go for the through curve. See here, another round. You can control fillets or draft as per your requirement. Draft for the cylindrical surface, neutral plane as the bottom plane. This is my neutral plane. You can give the draft angle. See here, like this. Suppose you can blend it. You can go for the blend. See here, extend the intersecting surface area, or you can go for the blending the corners. Type of blends you have, like that. Suppose if you would like to go for the draft on this face with the help of neutral curve. This is a neutral curve. The perpendicular to neutral curve is the vector direction. See here. Through curve, I go for split at neutral curve. See here. Split at neutral curve. The option draft after dependent, independent, through neutral curve. These are very important to understand it. With the help of these concepts, we are going to go for the complicated models. And suppose I want to create different planes, points, lines, but we may have the options in point only or axis. Suppose you would like to create an axis. Just you click on the cylindrical surface, you get an axis. switch it off it. See here. Axis. And suppose if you would like to go for the creation of an axis, so intersecting the planes. See here, intersection of two planes. You're going to get an axis, horizontal. Or if you want to go for the intersection of vertical planes. See here, vertical of intersection. In same options only we have to create with a reference of x and y hole. See here, at x and y hole, are going to get an axis. The same axis on edge, are going to get it. On curve, perpendicular to curve, between intersection of two curves, like that. Like that, you have the different planes creation methods also. Through planes, through two lines. Perpendicular to this curve, plane, normal to this curve. At this point on this curve, perpendicular. You can go for the 50% normal, parallel, or you can go for the percentage wise as per your requirement, normal to curve. And if I know 3 points, suppose I have 1 point here, I have another point here, I want to create another plane here, passing through 3 planes, 3 points. See here, angular plane with through this axis, coinciding angular planes like that. These are important features where we can go for the complete applications as per our requirement, and then we can convert these points, planes, axis, and curves, types of curves, the datum curves, different curves. Then we can convert from surface to solid to surface like that. Sorry. Hello, hello. Hello, excuse me. Hello, sir.
Yes, sir. Yes, sir. Yes, sir. Tell me, sir.
Yeah, I think it is time is 4. Remaining thing I would like to continue in the session.
Okay. Taha, whether time is there for question and answers or?
Yeah, please.
Okay. Okay.
Okay, surely. Because of time schedule, somewhat we have made it fast. With these basic concepts, we have so many examples to show you. We have engines, we have two-wheeler engines, and so many parts are there to show. If I spend that time by showing the other parts, how the basic stages or any educational institutions, the private educational training centers, but people must know and they should go for the complete applications to understand in depth. That is our main motto. If they are thorough in the software and with the engineering, understanding the drawing concepts, they are going to get the jobs anywhere they are going, because they are going to throw in the interviews. Our main motto is to tell them how they should expertise in the manufacturing process, understanding the drawings, understanding the features in the softwares. That is our main motto. So we have made the categories. Tomorrow I would like to continue with the surfacing concepts, but right now I have basic things of the part design I have covered. Only 2-3 commands I have covered by explaining what is the solid modeling, surface modeling, and wireframe and hybrid design products. Then I have continued like that. Any queries students can ask, please.
Hello.
Yes, sir.
Hello.
Yes, sir, please.
This is.
Yes.
Can I speak?
Sorry. Yes, sir.
Thank you, Mr. Govind.K.Handigol, for explaining the basic conceptual designs and softwares with their application.
Welcome.
I have a small question.
Yeah, please, sir.
CAD and Unigraphics, both are
Yes.
used for the same applications, no? Same application, but
Same applications.
same application.
But,
now, which is best one compared to CAD? Unigraphics, is it?
sir. CATIA is mostly we use it for the Aerodynamic applications, aerospace, the sheet metal and surfacing design applications. CAD is most worldwide used.
But
Aerodynamic application, development of submarines, satellites, everything. CAD is one of the best software, sir. All
early,
engineering students must have this knowledge. But for
ah,
Unigraphics is used for manufacturing based applications. The CAM is very strong in the Unigraphics software. That is NX. NX is worldwide used for hybrid design product as well as the manufacturing concept. The CAM concept they have given very good in the Unigraphics software, sir. But whereas CAD is used for aerodynamic and sheet metal and advanced surfacing applications, sir. Tomorrow I am going to cover the CATIA surfacing concepts.
that's why I asked you this question. Earlier, our students used to learn Unigraphics software.
Yes.
But now I don't think most of the students are familiar with Unigraphics. So that's why I asked the question. But
Yes, sir. Yes, sir. But the students are going to get the much more knowledge in the CATIA, sir. They have not made any confusion in the software. But any students they starts with the Unigraphics means the more options are given in the Unigraphics softwares. CATIA they have made very systematically, sir. Freshers can be easily understand the software and they can go for the jobs. But the more jobs are going to get students in the SolidWorks and Creo, sir. More jobs. Initially, up to 2012, we have made the 100% placement in our technical institution. 2012 onwards, 13 onwards, the more engineering colleges, more NTTF, diploma colleges, JTTC opened. So we have made around 50 to 60% placements. Those students are learning with us, sir. But we will make them 100% eligible for the drawings and other interviews like that. Live projects we are going to give them, sir. Yes, sir. Mines? Yes.
hello, am I audible now?
Yeah.
Thank you, Govind, for your nice presentation.
Thank you, sir. Thank you.
Tomorrow also, I will
Yes, sir.
listen to your lecture. Okay.
Fine, sir. Fine, sir. Fine, sir. Thank you, sir.
Okay, I take this opportunity to thank our Department of Mechanical Engineering,
Yes,
especially head of the department and for organizing this webinar, which is very useful for our mechanical engineering students. Thank you very much.
Thank you,
If
sir.
there are any questions, our faculty will ask our students.
Please.
Okay, let them know. Thank you. Thank you.
Sorry. Yeah. For the fresh, the question is that which is the best software for the mechanical machine design? He is asking. The answer for this is actually almost all the CAD means computer designing. They are going for all the softwares for the machine design applications. If your knowledge-based applications are going for the machine design, the CAD is one of the best software. If you are going for the job-oriented applications, basics with AutoCAD two-dimensional drawings, you must understand the Pro Engineer or Creo the software. Then you must know the best software for the machine design. Yes, any queries? Thank you. Welcome. Here, another question is there. How do you determine the margin of error while designing? See here, any products will not be manufactured to the drawing dimensions exactly. For that, they are going to give the tolerance, deviation to the original value. So we must have the options. The Pro Engineer has got 0.00125 mm tolerance for all the modeling applications. Like that, or AutoCAD has got up to 8 digital precision. Like that, different softwares have got tolerance and its other applications are there. And apart from that, the standard tolerance drawings you have to refer if they are not mentioned. Like that, according to the dimensional concepts, we must go for the different concepts. And also we must know the GD&T concepts of 14 symbols. All those parameters are going to help for the assembly and manufacturing. Apart from that, we have the basic datum A, B, C features. Those things I will explain you the day after tomorrow while explaining the CAM concepts and current cavity extraction. Their datums are very important. With those concepts, we are going to judge and understand the references. Then we can go for the manufacturing with the help of CNC programming concepts. Yes. Thank you. Yes.
Hello. Hello.
Yes, sir. Yes.
Hello, Govind sir. Namaste.
Namaste. Yes.
This is Vasarappa from Mechanical Department, AIT.
Yes, sir.
So, sir, am I audible?
Yes, sir. Audible. I can hear.
Your presentation was very nice, sir.
Sorry, sir. Because of time schedule, I could not show in detail. But basic concepts I have cleared, I think so.
As an academician, we have a limited knowledge of industrial demand.
Yes, sir. Please, sir.
Most of the commonly asked question by our students after completion of the degree, which
Yes.
is the most demanding software in the market, because it will vary from time to time. Which is the most demanding software as on now?
For the engineering freshers, if you consider fresh engineering students, they are going to get the jobs in the Creo, because more number of licenses are there in India in Creo only. Creo and SolidWorks. They are going to recruit for the freshers. If they have the thorough knowledge in the drawings, if they have thorough knowledge of the GD&T concept with software knowledge, they are going to recruit. No, they are not worrying about the experience, other things. Because of the more number of licenses, more opportunities they are going to get in the first preference in the Creo or Pro-E. Second will be the SolidWorks, third will be the Autocad. Then if they have 1 year experience, they can go for the CAD and Unigraphics.
Thank you, sir.
Thank you. Welcome, sir. Yes, sir.
Okay, shall we end the session? Any questions are left?
Any question?
Yes, sir. Yes, sir. Thank you, Govind sir, for today's session.
Yes, sir. Welcome.
Today's session. I request all the participants to join tomorrow at 3 p.m. Thank you.